Oh, it's going to be a party today, guys. All right, my early friends. So go ahead and get started on these three graphs. I recommend making a table, maybe with values like -1, 0, and 1. Those would be good. Welcome to those of you refugees from Miss Weese's class. It's going to be a good time. Yes, this is the right class, Caden. Are you in Miss Weese's Honors Algebra 2 class, honey? Miss Weese isn't feeling well today, so that's one of the good things about virtual schools. There are 3 Honors Algebra 2 classes at the same time. So she sent half of you to my class, half of you to Miss Salisbury's class, and you're going to get the same lesson regardless. So welcome to my basement instead of Miss Weese's playroom. All right, we're supposed to have like 45 people in here. Where is everybody? Got a couple minutes. They better get in. All right, ladies and gentlemen, you should be titling your notes, Student Learning Task 23, Graphing Logarithmic Functions Expressed Symbolically and Showing Key Features of the Graph. Today is November 12th. We are welcoming approximately half of Miss Weese's students into our class today. We do not have a ton of new students. She's not feeling well, so I have half of her students. And Miss Salisbury also teaches Honors Algebra 2 at 4th period, so she has the other half. You'd be so kind as to pop those cameras on. It is nicer to teach to faces or even to your ceilings than it is to teach to those little black squares. The black squares are depressing, guys. Come on, pop them on. I'm going to give you another 2 minutes or so to get these functions graphed. You did have the announcement yesterday, and I sent it out. I think I sent it even Monday. That this was a lesson that it's helpful to have printed. If you don't have it printed, that's okay, but just be aware that I'm probably not going to wait for you to write down absolutely everything. I don't need the bottom of these graphs, so I'm gonna paint them white so I have a place to write. Okay, so as you are getting settled, let's just go over these graphs. My suggestion was to graph tables, for those of you who are a little early, with -1, 0, and 1. So let me get my handy dandy yellow cards. So Isadora, if we plug -1 in for x for number 1, what do we get?
1/2.
1/2. Very good. If we plug 0 in for x, what do we get?
1.
1. And then if we plug 1 in, we get
2.
2. All right. So when we graph these, here's -1, 1/2, 0, 1, 1, 2. And if we kept going, it would be 4 and then 8. And we would have a beautiful exponential growth curve. Let's see if I can get it to be beautiful. Oh, that's not bad. Not bad at all. Oh, except the end there, I choked. And we always want to make sure we draw our asymptote. Here we have a horizontal asymptote. Well, I feel like that's white. It's white. That's not good. There we go. And there's our exponential function 2 to the x. So now we're going to do the same thing for 1/2 to the x. We're going to have -1, 0, and 1. Wait, see, this is like a problem because I got so many of you. I do not know if these people are here. Aiden, are you here? You're on, like, you guys are on like many screens.
Yeah.
Aiden, if I put -1 in for x, what do I get?
For number 2?
Yes, sir.
You get 2.
Bam. What about 0?
1.
Beautiful. And then 1?
1/2.
Love it. So let's see. 2, 1, 1/2. And then up here would be 4. And then up here would be 8. And there's our exponential decay function. And here is its horizontal asymptote. All right, Mr. Jack Brick, number 3. Oh, someone fell out. Jack Berg, if I plug -1 in for x, what do I get?
Do you get 1/10?
I get 1/10. Then what about 0?
0. Or I mean 1.
1, good catch, good catch. And then 1,
10.
10. And that's going to be an exponential growth function. And I don't know, I don't think I have enough spaces. 8, like 10's up here somewhere. That is a really steep growth function. Arrows, asymptote. All right. So we have graphed exponential functions in the past. This is not new. We're just using tables to graph. Again, I would like to welcome the refugees from Ms. Weiss's class. Congratulations, you found the right class. It's the exact same lesson, just with more sarcasm, and the jokes are significantly worse than Ms. Weiss's class. Announcements for the day. Announcements. Do you have homework tonight? Please make sure it gets done. It is due Sunday for everyone. It is Q2, day 3. Also, as a reminder, your quiz is due Sunday. This quiz is reassessable. However, do not take it a second time until we grade the first one and you've come to see us. Okay, if you take them one right after another, it's going to be sad. Sad indeed. All right. So if you need to snap a picture of those announcements, go ahead and do that. While we're waiting for some people to just finish getting themselves settled, my friends, if you have homework questions, in the chat privately to me, which homework questions from last night do we need to go over? I know there's a few, because I checked your homework. Which ones do you need me to elaborate on? Oh, 11 apparently was tricky. 2 people are talking about 11. 11 and 16, 11E. Let me make this window bigger. All right. So let's talk about Lauren. I'm confused. Is it 11D? Okay. Someone asked about number 9, and that's a good one to look at. So let's real quick look at number 9. This one should be obvious. X raised to what power gives you X? It's just 1. Now, all the other ones are not going to come out exact. So you need to kind of think about, all right, well, 7 to what power gives me 45? I don't know, but I know that 7 to the first is 7. I know 7 squared is 49, and 45 is way closer to 49 than it is to 7. So that's why I say, all right, this guy, he's a little less than 2. Did they not rank these largest to smallest? That's sad. So then 3 to what power gives you 12? Well, 3 squared is 9. 3 to the third is 27, but it's closer to 9, so it's a little more than 2. Person who asked about number 9, are you following my logic with how I'm coming up with these values? Okay. And then, I'll be honest with you, I think the ranking is a little tricky. Obviously 1 is the smallest. And then the problem comes in these 2, because they're both a little less than 2. So then proportionally, even though they're both 4 away, 45 is 4 from 49 and 12 is 4 away from 16, proportionally, log base 7 of 45 is closer to 2 than log base 4 of 12. Are we good on number 9 person? Okay. A lot of people want to talk about 11E and 11D, and then some others. So 11, I'm assuming this is D and this is E. Okay. So am I right? That's the right assumption? Okay. So Lauren, 2 raised to what power gives you 1/10? I don't know, but I know that 2 to the negative 3 would be 1/8, right?
Yeah.
Okay, and then I'm not sure I agree with that. 2 to the negative 4 would be 1/16. I think this is a typo. It should be -4. No. Yes, a little less. I'm so stupid. Less than -3 would be closer to between -3 and -4.
Okay. Yeah,
Okay.
I don't know. I'm just like brain farting on that one because I did all the other ones right.
Yeah, I like kind of brain fart there with the less than a -3 is not going to be like -2. It's going to be like -3 point stuff. And then someone asked about E. So 2 raised to what power? So like, man, I got to think about I need to be like able to go 2, 4, 8, 16, 32, 64, 128, 350, 256. And if you can't do that, I don't know what class you all think you're in. This is Honors Algebra 2. We can multiply by 2 without a calculator, right? Okay. So that was 1, 2, 3, 4, 5, 6, 7. So somewhere between 7 and 8. And it's closer to the 1. I don't know that it's really that much closer, but it's somewhere between 7 and 8. Okay. So then for 9, how do I know to not make it a fraction? Because none of the only one I could maybe make a fraction is the middle one, because 4 is a perfect square. But then like no power of 2 gives me 12. So that's not going to work. That's how I knew not to make it a fraction. All right, so 16. A lot of people wanted to talk about 16. Now, I'll be straight with you. I think some of you super cheaped out on this homework, and it really pissed me off when I was grading that you were just like yes or no. And I made comments in some of your homeworks that this would not be acceptable on a quiz. So please make sure you read those comments. You know if I'm talking to you. Number 16, does it have an answer? Yes, it does. X raised to what power gives me x to the 5th? 5. Does log base x of 1 have an answer? Yes. X raised to what power equals 1? 0. This is the only no. A couple people who I graded your homework, you had really good answers for number 14. Hey, Kennedy, you had one of the really good ones, didn't you?
Yeah, you put a note on my
Oh,
homework.
I did. Okay. What did you write down?
I said that no, because x to a power will never equal 0.
I need a reason. You can't just say yes or no. If yes, give an example or the answer. If no, explain why not. This is Honors Algebra 2. I expect you to read the directions, ladies and gentlemen. I think I covered all the homework questions, but it was a long list. Yeah, I got them all. And that was a bonus. Nobody even asked about 14. All right. Ladies and gentlemen, today we are going to look at graphs of logarithmic functions. If you did not print the notes, just be aware that I'm not going to wait for you to write everything down. It's not necessary. And if you really want it, you can print it out or get it later from the notes in class. So this is what we're going to do. This was our graph that we made for the warm-up. This is a graph of 2 to the power of x. So on the same grid, we're being asked to graph the relation that represents the inverse. If I have a set of points, Jason, what can I do to that set of points to graph the inverse?
For the set of points, you just flip it.
Yep.
The other side.
So this is going to be 1/2 -1. This is going to be 1, 0. This is going to be 2, 1. And then they even got the 4, 2. So I'm going to graph those looking pretty. And you can just put these right on your warm up if you want. That is fine. 1/2 -1, 1 0, 2 1, 4. Oh, I missed. Okay. Now, this graph has kind of a flat portion here along the x-axis. The inverse is going to have sort of a flat portion along the y-axis. The exponential growth shoots up. The logarithmic function is going to shoot off to the side. If you tilt your paper and you look at this line y equals x, you should see that these graphs are reflected over the line y equals x because they are inverses. All right. Okay, so number 4 says determine the domain and the range of f. I want to be super clear when we're talking about f of x is the exponential. Okay. So I want everyone to pop open your chat. And I want you to type the domain of the exponential, but do not press enter. What is the domain of the blue graph? Do not press enter. Press enter. Oh, I got one person gave me something else, but all real nubs, that's adorable. All real numbers. The domain of this graph is all real numbers. All right, same thing on the range. With good notation, what's the range of the exponential function? Do not press enter. Press enter. Hey, look at that. Almost everyone's got it. Okay, good notation is going to be y is greater than 0. Are there any questions on the domain or the range of the exponential function? Either type it into the chat privately to me or be brave and unmute yourself and ask. Okay. So now number 5 is asking us for the domain and the range of the inverse function. So this purple inverse function, again, I want you to go ahead, pop open your chat, type the domain, but do not press enter. Press enter. All right, look at that. There we go. Now they're all coming in. X is greater than 0 is going to be the domain for our inverse. I want you to type in the range for the inverse, but wait to press enter. Go ahead and press enter for the range of the inverse. Very good. The range of our inverse is going to be all real numbers. I want you guys to notice the domain of the original became the range of the inverse. The range of the original became the domain of the inverse. Okay. The original function was f of x equals 2 to the power of x. I want you to make a note that our inverse function is log base 2 of x. Now, my purple graph is missing something. I need a brave person to unmute themselves and tell everyone, what is my purple graph missing?
It's missing the asymptote line.
It's missing the asymptote. Heiko, is that you?
Yeah.
All right, it's missing the asymptote line. Oh, wait, I wanted that to be purple, so it would match. There we go. All right, this has a vertical asymptote at x equals 0. So make sure you dot that asymptote in. All right, the last question on this slide asks, are both of these graph functions why or why not? Use the hand raise function on your participants bar. Do you know why they are functions or why they are not functions? Nope. Margot, what do you got?
I actually don't know for sure, but I'm just gonna take a swing at it. I think the functions because you can like you don't like each number is individual. You can't have a repeating 0, 1 or like it's not like a parabola where it's just like a loop.
I'm going to pause you here. You're thinking about a one-to-one function, and that's not wrong. But we're going to make this a little simpler. This is a graph. Margot, we have a special test we can do to a graph to determine if it's a function. It starts with a V.
Visualize?
Not visualize. That's a good V word. I like it. I'll give you a hint. V-E-R.
Vertical.
Vertical what?
Lines.
Sophie, help him out.
The vertical line test.
They both pass the vertical line test. The vertical line test is when, remember, we draw the vertical lines through the graph, and if each vertical line only passes once, it's a function. I don't want to yuck up my graph, but like, here's one, and I'm like, look, the vertical lines only touch once. And if I have this graph, you have to remember this is very slight. Like, it's not perfectly vertical there. Okay, we're gonna do the same thing now with our middle graph from the warm-up with y equals 1/2 to the x. This was the table we used to graph y equals 1/2 to the x, and now we're gonna graph the inverse. But first, apparently, we want to say the actual function, the inverse of x. If I have the exponential function 1/2 to the power of x, its inverse function is going to be log base 1/2 of x. I'm using red. So now I'm just going to flip them around. And again, it's going to have a vertical asymptote of x equals 0. And I kind of want to make sure I draw it so it's got that reflection over the line y equals x. Once you have your graph complete, I want you to jot down the domain and the range of the log function. Once you have the inverse graph done, once you have log base 1/2 of x graphed, I want you to jot down the domain and the range of log base 1/2 of x. The inverse, someone just asked me, why is the inverse a log function? Remember, when I have an exponential, that's like base to the power of x. And when I have a log function, that's like what power of the base equals x. Remember, like if I have an exponential, that's like 2 to the third. Well, what's 2 to the third? Y'all better scream it out loud. What's 2 to the third?
8.
8. And then when I think about that as a logarithm, that's like log base 2 of 8. 2 raised to what power gives me 8? Person who asked about that, are you good now? Cool. All right. Ladies and gentlemen, type the domain of our log function in and press enter. Oh, apparently we're all typing privately to me. And some of us to everyone. All right, some people put it privately to me, some people put it to everyone. You are correct. It is x is greater than 0. Even though this graph looks really different from log base 2, it has the same domain. It also is going to have the same range. The only difference between log base 2 and log base 1/2 is that this graph is decreasing. It's decreasing when x is greater than 0. It doesn't increase because it has a decay base. What is the asymptote of our inverse function? Everyone should know that one. That's just going to be x is equal to 0. How is it related to the graph of f? It's just the inverse. All right, we looked at the first graph we did in the warm-up and it's inverse. Then we looked at the second graph we did in the warm-up and it's inverse. Now we're going to look at the third graph and it's inverse. Someone asked me, why is the asymptote x equals 0 and not y equals 0? If you look at this red line, all the x values on this dotted red line are 0, like -5, 0, or sorry, 0, -5, 0, -10, 0, 1. All the x values are 0. On the purple line, this is y equals 0 because all the x values are -1, -2, -3, -4, -5, and all the y values are 0. Does that help? Cool. All right. Third inverse. Now, we're not going to use that many points. This one was 10 to the power of x. You'll see I just have 2 points graphed because 10 is big, man. So I have 0, 1. I mean, I could have had -1 and then 1/10. That would be okay. It would be the end of the world. 1/10, -1. We'll make it pink. And again, you really want to be conscious of the fact that it's a reflection over the line y equals x. And it's got this vertical asymptote here at x equals 0. I'm just going to answer the questions that are below up top. I don't feel like moving everything around. If the base of the exponential is 10, the base of the logarithm is also going to be 10. This has a special name. We talked about it yesterday. I need a smart person to unmute themselves. What do we call it when it's base 10?
The common base.
The common base. Because it's the common base, Ella, how can I write this like shorter?
You can just write log and then x.
And then x, and then Ella, if anyone asks what the base is, are we going to roll our eyes at them?
Yes.
Yeah, we are, because they didn't remember that when you don't see a base there, it's base 10. They're the same thing. So write that down. Like if you were making a summary sheet, that would be a good thing to put on your summary sheet, don't you think? That would be a good thing. Base 10, the common base. All right, so make a little note here. Invisible 10. All right, I need for F inverse, I need the domain and I need the range. So everybody write them down. All right, Trias, what's the domain?
X is greater than 0.
X is greater than 0. Perfection. Joss, what about the range? Oh, wait, she's somewhere today. She sent me an email. Elijah, what's the range?
All real numbers.
Bam, all real numbers. Now, I want everyone to trace this graph from left to right. Oh, I forgot the arrow. Isabella, does this graph increase or decrease?
This graph decreases.
Okay, ready? From left to right.
Oh, it increases.
It increases. So I know that this graph is going to increase when x is greater than 0, and I know that it's never going to decrease because it always goes up. So what we've done here is we've graphed 3 different parent functions. We graphed log base 2, we graphed log base 1/2, and we graphed log base 10. So now what we're going to do is we're going to graph some log functions without starting with the exponential. When we did these 3, we started with the exponential and we did the inverse. Now we're just going to straight graph the logarithm. So if you printed this out, great. If not, you are writing this down anyway. I need everyone to write down, select x values for the table that makes the argument powers of the base. And then I will explain what that means. Select x values for the table that makes the argument powers of the base. I know we just graphed this, so just play along. It's like the teaching example. Hey, Kevin, what's the base for number 1?
The base is 10.
Base is 10. What are powers of 10? What's 10 to the, all right, whoa, hold on. What's 10 to the first?
10.
What's 10 squared?
100.
That's kind of big. I don't know if I'm gonna graph that. What's 10 to the 0 power?
1.
What's 10 to the negative 1?
1/10.
Good. Do you see what I mean, Kevin? I'm gonna pick X values that are powers, like, of the base. That way, when I go and plug these numbers into my log equation, duh, what's 10 raised to what power gives me 1/10?
-1.
Good. Hey, Kevin, 10 raised to what power gives me 1?
0.
0. 10 raised to what power gives us 10?
1.
You see how we're setting ourselves up for success here? If we pick values for X that make the argument, that make what's in parentheses powers of the base, the arithmetic is going to be lovely. So I want everyone to graph these and fill in the properties. Four. Oh man, this is so hard. There we go. Good enough. How does my graph look? Is my graph beautiful, Omar? Are you reveling in its beauty?
It's decent.
It's decent. Is it missing anything? Is this going to get me full credit?
Vertical asymptote.
Damn, forgot the vertical asymptote. Gonna need that. Don't forget it. It's important. What's the equation of that vertical asymptote?
X = 0.
Bam. Hey, while I have you unmuted, what's the domain?
Domain is X > 0.
Beautiful. The range?
All real numbers.
These are kind of familiar, aren't they?
Yes.
Yeah, until we start moving things around, not a lot's going to change. Does this graph increase or decrease, Omar? What do you think?
Increase.
It increases, and it increases over the entire domain, and it never decreases. Are there any questions on graph 1? Remember, the difference here is now we're just graphing the log function without also doing the exponential. So now we're going to graph f of x equals negative log x. Here's my question. What's the base? Angelina, what's the base here?
10.
10. The argument's just x, right? So we're looking to make the x values powers of the base. So again, we're going to use 1/10, 1, 10, and we'll just put 100 in for fun.
Why does the log have a negative?
Because it's a different graph. We'll play along for a second, Marco. It's gonna make perfect sense in like 2 seconds, okay? I promise. So Marco, see how this one I'm like actually writing down all the arithmetic? So I'm writing down all the arithmetic. Okay, so now I'll evaluate the first one. When I look at this, I have 10 raised to what power gives me 1/10? It's -1. But wait, there's negative here. Negative -1 is just 1. Angelina said it, I saw her. So now, Margo, when I do 10 raised to what power gives me 1, that's 0, -0. You following me, bud? Okay. So everyone go ahead and fill in the last two on your own. So 10 raised to what power gives me 10? That's 1, 2, if you know the transformation that we just graphed, I want you to type it into the chat to everyone, but do not press enter. If you know the transformation that we just graphed a transformation, type it into the chat, but do not press enter. If you know what it is, press enter. Ooh. Ariana's got it. Ella's got it. Okay, I like the reflect. Make sure we're saying that this is really a reflection over the x-axis. Okay, not just reflect, guys. So make a little note. Remember, this negative is a reflection over the x-axis. And what happens is that now we have no increasing interval, but instead the function is decreasing. All right. I want to get 1.5 more graphs done in the next 4 minutes. Okay, so if you don't have any of this written down, it's okay. It will be in the notes for you later. I want to do...
It's greater than 0 for the decrease. It wouldn't be x
is greater than 0.
Oh, okay.
I want you to write down for number 3 is log base 2 of x. Remember, we want to pick x values that make the argument, x is the argument, powers of the base. Lauren Clark, what's our base?
It's 2.
It's 2. Give me some powers of 2. What's 2 to the first? I think Lauren froze. Lauren, go like this. Yeah, she froze. We'll come back. Hey, Lauren McClure, your card is next. How about frozen Lauren out? What are some powers of 2?
4.
4.
8.
And then 8. Lower. What's 2 to the first?
2.
What's 2 to the 0?
1.
Good. What's 2 to the -1?
1/2.
1/2. Oh man, Lauren Clark fell out of the Zoom. Do you guys see how we're finding these x values? Like we're literally thinking, all right, well, 2 to the -1, 2 to the 0, 2 to the first, 2 squared. Oop. Because then when I do log base 2 of 1/2, it works out perfectly. I don't want to pick random numbers because otherwise it's going to be like a hot mess. I don't know what log base 2 of 3 is. 3 would be a terrible idea. But I know what log base 2 of 1 is. I know what log base 2 of 2 is. I know what log base 2 of 4 is. Those are nice. Make sure my graph has arrows. Want to make sure my graph has a really clear vertical asymptote. I'm going to make a note that my vertical asymptote is still x equals 0. My domain is still x is greater than 0. My range is still all real numbers because I haven't done any other transformations yet. That is for another lesson. Hey, Lauren, you unfroze. Welcome back.
Yeah, I froze right as you started asking questions.
Oh, man. Don't worry, Lauren McClure bailed you out. Say thank you. All right, I want to look at one more problem and then I'm going to let you go. We're not even going to finish it, but it's an important one, so I want to make sure we touch on it. So we have log x, which is the common log. It's one of our special buttons. Everyone lean in. See the calculator? See under log? What does it say under log? So it says, what button is that?
2 to the power of 10.
No, like the button, like this guy. So here's the log button. What? And then you got this one. See how it says ln? You see what it says above the ln? ln, I want you to make a note. ln is log base e. We use it for continuous growth. Now remember, e is just like 2.7. So if I was making a table, this would be like the most boring table ever. I could use like 1, 2.7. This would be 0. This would be 1. It would not be very, it would still be a growth. It's not going to be very exciting. Then 2 points like here. It's still going to have the same asymptote. It is still going to have the same domain. It is still going to have the same range. And because 2.7 is a growth base, it's still going to look like 2 to the x. Oh, that is so ugly. Strauss, come on with that terrible drawing. It's just going to be slightly different shape because the base is 2.7 instead of 10 or instead of 2. But I need you to put that on your summary sheet. ln is log base e. Okay. Thank you for being patient. I'm sorry we went a little bit over. No, actually, wait, what am I talking about? We have time. Strauss, come on. You got 10 whole minutes. Oh, this is so exciting. Why did I think we were done at 2:30? I know, Angelina, this is the greatest thing ever. I don't know why. Why don't you all say something? Why did I think we were done at 2:30?
You weren't paying attention to time.
I was not. Well, I was paying attention to time. What was I looking at that said 2:30? I don't even know. It's okay. We got a little bit. Now we can relax ourselves. Increasing. Is there any page you need me to flip back to? We went kind of fast on some of them. Like all these graphs, they do look kind of similar because if they have a growth base, they look like a growth. If they have a decay base, they go down.
Are these techniques to get the same like equations?
Yeah. Like Kevin, we're always, even once we start doing transformations, we're going to use the technique of picking x values that are powers of the base. That's going to be a technique we're going to use very shortly when we start transforming things. Like a little note, it's called the natural log. My refugees from Miss Weiss's class, are you all alive? Those of you that are left. I'm giving her the Zoom record so she'll know how long you were here. So good job, those of you who stuck it out to the end. Are there any questions on graphs of logarithmic functions? All right. If you are good, if you don't need me to go back, I'm happy to go back and show you whatever you need to see. You need to see this one. If you know what your homework is for tonight, you know you have a quiz to take this weekend. You are free to unmute yourself and say goodbye. If you have questions, stick around. I'll stop the recording and answer any questions you have. Bye, guys.
Bye.
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 We've done a little early because I can't tell time.